Section 5.8, average value of a function. Let's suppose we have an x-axis, y-axis. We have some kind of function, y is equal to f of x, okay? Let's see how we come up with the average value formula for a function. Now, let's suppose I'm looking between a and b right here, and I want to find the average value of this function. So what I'm really looking for is like, what is the average y value? What is the average output, okay? Now, how would you find the average of a set of numbers? Say you have four numbers, like 5, 8, 13, and -2, and you want to find the average. You would just add up the four numbers and divide by 4, right? We're going to do a real similar thing here, okay? Let me take this interval from A to B. Let's just go ahead and split it up into 4 equal intervals. So we're going to split it up like this, split it up like that, split it up like that, okay? And what would this width right here be? Let's suppose I call that width of my interval delta x, okay? What would delta x, the width of each one of those intervals, be if I made them all the same width? Let me go ahead and put it maybe up here, okay? If I can get this thing to right. Delta x is a width. What would the width be? Well, it would be the whole length of this interval from A to B divided into 4 equal sections if I made them all equal length. So it'd be the width of the interval, which is b minus a, over the number of intervals, in this case would be 4, right? All right, anyway. And let's pick some points in these intervals. I like to pick the midpoint of the interval right here. And let's call that point x1 superscript the star, okay? Let's call this midpoint x2 superscript the star. This one we'll call x3 star, and this one we'll call x4 star. Now, if I look at my function height right here, right there at x1 star, that'll be f at x1 star. If I look at the height of my function at x2 star, what will that be? That'll be f at x2 star. How about the height of my function at x3 star? Well, guess f at x3 star, right? And your height right here would be what? F at x4 star. Now, what if I wanted to find the average height using those 4 values as heights for my function, okay? What would I say? I'd say the average height, or AVE or AVG, however you want to say it. What would that be equal to? That would be adding up all of these values here, f at x1 star plus f at x2 star plus f at x3 star plus f at x4 star, and dividing by the total number 4, right? Now remember, that's if we're trying to find the average height or the average y value or the average output given 4 values. All right, now what if I'm given a continuous function from A to B, but I'm given an infinite number of values in here? How do I go about finding the average height or the average y value or the average output if I'm given an infinite number of values there? Well, let's see. We're going to do a very similar thing to what we just did. All right, let's suppose I have a bunch of y values, okay? All right, here's my x-axis, here's my y-axis, here's my curve. Y is equal to f of x. I want to look between A and B, and I want to see what is my average height between A and B of this function? I would say it'd be somewhere around there, it looks like, if I were to eyeball it, whatever that y value is there, okay? But I'm going to do like I did in the last example. I'm going to split these up. I'm going to split this interval from A to B up into a bunch of different sections, okay? Well, I can't draw a straight line to save my life right now. Okay, dot, 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 I'm going to put stuff like this, okay? Now, what I'm going to do is I'm going to pick a point right here, halfway between this interval right here. I'm going to call that x1 star, okay? So what would this height be? F of x1 star. Then I'll pick a point right here. We'll call that x2 star. So this height will be f at x2 star, right? Then I could pick an x3 star and so forth. And as you can see, it gets very, very crowded right here. So that was x2 star, this was x3 star, and so forth. And the height would be f of x3 star. And I could keep on doing that. Like I have a bunch of different partitions in here. I just don't feel like drawing them all right now, okay? And let's see, let me put A and B back on here. That's what teeth are used for, huh? You dentists will say, do not ever do that, especially whenever you open up beer bottles. All right, let's see. Keep going on. And then let's suppose right here we have x subscript of n star. So what would this height be right here? F at x subscript of n star, right? All right, again, I want to find the average of my y values. I want to find the average of my f of x values. So I could say average, AV, AVG, whatever you want to use, would be what? Adding these all up, f at x1 star plus f at x2 star plus f at x3 star plus dot, 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 plus, and my final one would be f at x n star if I'm adding up n of them, okay? Dividing by the total number, right? Which would be n. That's how I find my average of those n values, even if I drew 100 of them here, okay? All right, so I could say that's the same thing as saying 1 over n times f at x1 star plus f at x2 star plus f at x3 star plus dot, dot, dot plus f at xn star. So really all I did here was factor the n out, right? Now earlier, whenever we said the width of each one of those partitions, or I could say each one of those values, each one of these segments right here, these intervals that I ended up breaking it up to, I said the width was what? For each one. It's the width of the interval, b minus a, divided by the number of partitions you made. Well, how many partitions did we make? We were looking at n of them, right? So we have this. Now, what if I end up solving for n in this equation here? So I could say n times delta x is equal to b minus a, right? Then I could divide both sides by delta x, so n is equal to b minus a over delta x. So I solve for n there. But what if I want to go ahead and replace 1 over n over here? So I want 1 over n, so I'm going to say 1 over n is the reciprocal of that. So reciprocate this side and you get delta x over b minus a. So what we're saying here is we can take 1 over n and replace it with this delta x over b minus a. Let's do that. Let's go ahead and replace this with delta x over b minus a times f at x1 star plus f at x2 star plus f at x3 star plus dot, dot, dot plus f at xn star. All right, so what would that be? That would be an average basically of what? N of those y values, right? That'd be an average of n of them. Well, what if I ended up doing this? What if I took my delta x here and I distributed it to each one of these f of x1s, f of x2s, and so forth? What would that give me? That would give me 1 over b minus a times what? F at x1 f at x1 star times delta x plus f at x2 star times delta x plus, now technically I need f of x3 star and so forth, but I'm out of room here, plus f at x n star times delta x, right? Let me see, I can do a rewrite now. I can rewrite this as 1 over b minus a, and then right here, let me go ahead and use this summation symbol, And I'm going to say this is f at x star. Remember whenever we use this notation that whatever's changing, we go ahead and call like our n value. So this subscript is changing, so I'm going to call that my n value. And I'm going to say let n, not n, k value, I'm sorry. I'm thinking of a different book. I'm thinking of a book I learned this stuff out of. All right, let's call that k, because that's the part that's changing, right? Let's say k starts at 1. And where does k end at? N, right? And what else do I have? I have delta x at the end of it. So I can write it summation like that. And I can say that's the average of n number of outputs, right? But I still didn't address the problem of an infinite number of outputs right here. How do I find the average of an infinite number of f of x values? Well, wouldn't it be this? The limit as n approaches infinity. The limit as n approaches infinity of this thing. 1 over b minus a times the integral from 1 to n, times the summation, where k starts at 1 to n, of f of x subscript k star delta x. And what is this? 1 over b minus a. That's just some number, so I can bring that to the outside of my limit. I can say that's 1 over, I can write b minus a times the limit as the n approaches infinity of the sum where k starts at 1, goes to n, of f at x subscript to k star times delta x. But what does this thing look like? What does this part look like? That looks like the definition of an integral, right? So I could say it's 1 over b minus a of the integral from a to b of f of x dx. So what does this give us? This gives us the average value of a function. So the average value of a function, or your book says, if f is continuous on the closed interval from a to b, then the average value or mean value of f on ab is defined to be f subscript abe is equal to 1 over b minus a times the integral from a to b of f of x dx. Memorize that, or else you'll have to go through that each time. Let's look at our example, our first example for this section. Let's see what they want us to do here. It reads, find the average value of the function over the given interval. They give you a function, they give you an interval. So for this first example, they say, let's find the average value of f of x is equal to 1 over the square root of 1 minus x squared over the interval from negative 1/2 to 0. And according to my formula up here, the way I find the average value is I do 1 over b minus a times the integral from a to b of f of x dx. So that's 1 over b minus a, so 0 minus negative 1/2, times the integral from a to b from negative 1/2 to 0 of f of x which is this function, 1 over the square root of 1 minus x squared, and then put your dx on the end. All right, so all I got to do is calculate that and have my average value. Let's do so. That's 1 over 1/2, right? Or could I say it's 1 times 2 over 1, or 2, times this integral. What's the integral of this? That's arc, or what? Inverse sine of x. And we need to use my limits of integration from negative 1/2 to 0. If we keep going here, we have 2 times the inverse sine times the inverse sine at 0 minus the inverse sine at what? Negative 1/2. So that's 2. What's the angle whose sine is 0? Wouldn't that be 0? Minus the angle whose sine is negative 1/2. Wouldn't that be negative pi over 6? So basically that's 2 times a positive pi over 6, or pi over 3 is my average value of this function from negative 1/2 to 0. How about the second example? How about it? Well, let's do it. Let's look at our second example. Second example reads, find a positive value of k such that the average value of, so here we have f of x is equal to the square root of 3x, and let's see, they say over the interval from 0 to k, and they want that average value to be 8, right? So it says find a positive value of k such that the average value of this function over the interval from 0 to k is 8. So we're dealing with the average value of a function. So what do I write? F AVE is equal to 1 over b minus a times the integral from a to b of f of x, right? It's my formula for the average value. Let's fill in. So we have 1 over b minus a is what? K minus 0 in this case. K minus 0 in this case. Times the integral from a to b, 0 to k, of f of x, which is the square root of 3x. So that's my average value, right? They want me to find k such that my average value is 8. So this average value needs to calculate to 8. So let's find our value of k. So I have 1 over k times the integral. I'm going to do a rewrite with this stuff. I'm going to call this 3x to the 1/2 dx is equal to 8. Now remember, each one of these exponents is understood to be 1 here and here, right? So I could take the 1/2 and multiply it by the exponent of 1, take the 1/2, multiply it by that exponent of 1. So we have 1 over k times the integral of 3 to the 1/2 times x to the 1/2 dx is equal to 8. Well, that's just a constant being multiplied by my function. So I can pull this constant out to the front over here. So I have 1 over k times 3 to the 1/2 times the integral of x to the 1/2 dx is equal to 8. So up front, I could put that 3 to the 1/2 over k. So 3 to the 1/2 over k. Let's take the integral right here. How do I integrate that? I say that's x to the 3/2 times 2/3, right? from what to what? Somehow I lost my limits of integration that were here. There were 0 to k, there were 0 to k, there were 0 to k. So then I run this from 0 to k, right? Should equal to what? Should equal to 8. All right, let's see what we have here. We have 3 to the 1/2 over k times, that's 2/3 times k to the 3/2, right? Minus 2/3 times 0 to the 3/2 is all equal to 8. Well, let's keep going. This part right here is easy. That just goes to 0, right? So I have 3 to the 1/2 over k times, this I could call 2/3 times k to the 3/2. We said all this goes to 0, so we have is equal to 8. Now let's simplify some stuff, okay? Isn't this understood to be 3 to the 1st? All of this divides, not all of that, crossed out the wrong one. So that's 3 to the 1st. All of this 3, or 3 to the 1/2 divides out with what? A half right here, 3 to the 1/2 here. And then what's left? Basically, you're subtracting the exponents. You're taking that 1 that was there, and you're subtracting 1/2 from it. All right, so you left it 1 over k times 2 over 3 to the 1/2. You write those on the same level. Times what over here? K to the 3/2 is equal to 8. Now, could I take the k to the 3/2 and multiply by this 1 up here to give me k to the 3/2 over k times 2 over 3 to the 1/2 is equal to 8? Now, what's understood on this k is my exponent, a 1, right? So this k divides out with one of them here, so I'm left with k to the 1/2 there, right? All right, so let's see what we have. We have k to the 1/2 times 2, or up in my numerator, I'm going to have 2k to the 1/2 over 3 to the 1/2 is equal to 8. Let's keep going. Could I multiply both sides by 1/2 right here? If I do so, I'll get k to the 1/2 over 3 to the 1/2 is equal to 4, right? Okay. Now what will happen if I square both sides here? It'll get rid of these 1/2s, right? So k to the 1/2 over 3 to the 1/2. If I square that, I need to square the other side, right? So what does that give me? If I multiply 2 by that exponent, I get k to the 1st. Same thing here, I get 3 to the 1st is equal to 16, right? Then just multiply both sides by 3. K is what? 64. I found my value of k. That'll make that average value of that function a what? An 8, like they said. Oh, I multiplied wrong, didn't I? It says 64. What is that actually? 40 what? 8. All right, let's look at the next one. Next one says, suppose that the velocity function of a particle moving along a line, or a coordinate line, is v of t is equal to 3t cubed plus 2. Erase this. So in this example, they say velocity function v of t is equal to 3t cubed plus 2. And they want me to find the average velocity of the particle over the time interval from 1 to 4. The average velocity where t is between 1 and 4. Let's do so. All right, how do I find the average value of a function? Because that's all I'm doing here, finding the average value of my velocity function, right? So this time, instead of f(a)(b)(e), I'm going to say v(a)(b)(e) is equal to 1 over b minus a times the integral from a to b of f of x usually, but this time it's v of t dt. So you proceed as we did in the last few examples. So we have 1 over b is 4 this time, minus a is 1, times the integral from 1 to 4 of v of t, which is 3t cubed plus 2 dt. Now remember, make sure you're able to do this yourself, and don't just blindly follow what I'm doing here. All right, so that's 1 over 3. Let's take an antiderivative here. What do we get? 3/4 t to the 4th plus 2t, and what do I need to run it from? 1 to 4. So we have 1/3, and then we have 3/4 times 4 to the 4th plus 2 to the 4th minus 3/4 times 1 to the 4th, 3/4 times 1 to the 4th plus 2 times 1. Let's see, let's close that, and we'll close that. There we go, make it a little neater. And technically, I mean, once you do this part, you can go ahead and just put this in your calculator. And then once you get the decimal, hit math, enter, it'll give you the fraction. So I got 263 over 4. This is what I got whenever I do that. And do they give me any units in this one? So I'm just stuck with that number, no units. All right, for the last example, it's very wide, I guess you could say, whenever you write it out, and it gets very, very messy on a board like this, so I'm actually going to do that one by hand, projecting down onto my paper, because it's going to get very messy on this board.